Hi. So this video is on mechanical properties of fluids. So let's get started. And the topic is surface tension. Only surface tension. It is a part of mechanical properties of fluids. So first, maximum radius required for a chalk to float on water, which is independent of its length. It is R max equals to under root 2t upon pi rho g. Next, what is the force that is required to pull a thick ring which is on water? Okay, the force which is required to pull the ring out of water is, now these tension forces will be acting downwards when the force which is being applied to remove the thick ring upward. Okay, so these two tension will act here, the downward, whereas the force will act upward. So what will it be? It will be the summation of weight and t into 2 pi r1 plus r2. Now thick ring has different radii, like this is r1, this is r2, like that. Okay, now if it is thin ring, then there will be only one radii, which I have denoted with r. So weight mg, wherever you go it will be there. So force is equals to t into 2 pi 2r. Here 2 pi r1 plus r2, and here 2r. That's it. Okay, because you can see here there is no extra radius, only thin. This is thin. Okay, we are considering a single radius for it. Now for disc or plate which is on water surface, as you can see, first weight mg will act, and then again here there is only one radii acting, so t into 2 pi into r. The force uh, is w plus t into 2 pi r. Okay, force which is required to remove the disc plate of the water. Next, a square frame. For a square frame, we know it is length L, same length, downward mg. Now tension is being acted on um, four vertices downward when force is being applied to remove the square frame. Okay, square frame. You know how a frame is. Okay, the frame will be like this, not like this. Okay. W plus t into 8L. Okay, 2 plus 2 4 4, 2 plus 2 4 4 plus 4 8. It's like that. Now what about for a square plate? Downward mg and t into 4L. Okay, next, what is surface energy? Surface energy, W is equal to U T into surface area. The amount of work done to form a liquid or mercury drop is W for liquid and W for soap bubble. So guys, for soap bubble you have to multiply all the formulas with 2, because there are films two films in a soap bubble, unlike a water drop or a mercury drop. So the amount of work done to form a liquid drop is T into 4 pi r square, and we get that from this formula. T is equals to surface area. Surface area of a water drop, which is the sphere, is T into 4 pi r square. Now work done to form a soap bubble into 2 kar dijiye. That's it. It has 2 films. That's the reason. Now what is the amount of work done to increase the radii from R1 to R2? W is equals to T into, again surface area. What is the surface area? 4 pi r square. Now R1 से R2 बन रहा है, तो इसलिए ऐसा होगा. Now when a bigger bubble, when a bigger drop of radii r is split into many droplets. Now when it is being splitted into many droplets, it absorbs energy. From the environment. So surface area increases, its energy increases, and surrounding temperature decreases, because it has taken energy. And the work done is positive because it has taken energy, and the surrounding temperature decreases. So we'll get the radius as n is equals to r is equals to n power 1 by 3 into r. So what is this? This is the radius of new drop. This is No, actually you will get, if they give the radius of the bigger mm, drop, then you will find out this, and if they gave this, you will find out. So it's like that. Just remember, r is equals to n power 1 by 3 into small r. Now w is equals to, so this is the work done, which took for a bigger drop to convert into n number of droplets. So this is the work done. As we know, this is how it starts with tension, area, 4 pi r square, एंड आर स्क्वेयर की जगह हमने आर स्क्वेयर डाल दिया और यहाँ पे ऐसा होगा, ठीक है। नाउ सिंप्लीफाई करने से आपको ये फॉर्मूला पे आप पहुँच गए। तब हमने पढ़ा कि एक बड़ा ड्रॉप, बहुत सारे ड्रॉपलेट्स बनेंगे, और अब हम पढ़ने वाले हैं बहुत सारे ड्रॉप्स जब एक ड्रॉप बनने वाला है, बड़ा ड्रॉपलेट से ड्रॉप, work done negative होगा obviously because it is being joined together and energy is required for such process. That's it. Wait a second, man, I didn't write it. So the formulas for work done and all same formula, okay? Don't take tension. Next, if the released energy is converted into kinetic energy of the bigger drop, then the velocity of the bigger drop will be, this will be the velocity. If the released energy is converted into kinetic energy of the bigger drop, and the velocity of the bigger drop, under root 6 upon rho into t into 1 upon small r minus 1 upon capital R, which is of the big drop. If the released energy is converted into heat energy, यहाँ पे kinetic, यहाँ पे heat, हाँ, then increase in temperature of the bigger drop is delta T is equals to 3T upon J into rho into S upon 1 into small r upon 1 into capital R. अगर आप पूछोगे कि S क्या है, S है specific heat of capacity, okay? When now excess pressure important है, ठीक है? Excess pressure inside a loop, inside a drop, which means P inside is more than P outside. Now delta P is equals to P in minus P out, which is equal to 2T upon R, और ये वाला फॉर्मूला आपको लगेगा एयर बबल, लिक्विड ड्रॉप एंड मर्क्यूरी ड्रॉप. But when so bubble is given, then you just multiply this with into this with 2, then you'll get 40 upon r, and this is the excess pressure inside a so bubble and a bubble, liquid bubble, mercury bubble. Okay, now the radius is equals to r1 r2 upon r2 minus r1. When, so this is the formula when one big bubble and one small bubble or a drop, now a bubble, okay, when they are like this, when they are combined, then there will be bulge at the surface of contact, and there will be more bulge towards the bigger drop, okay? So there will be a change in radius. The new radius will be r1 r2 1 r2 minus r1. Next, a bubble of radius r1 placed inside another bubble of radius r2, where r2 is greater than r1, then a single bubble which maintains the pressure difference same as inside the smaller bubble and outside the larger bubble. Outside the larger bubble is P0 and inside the smaller bubble is P1. Now P1 minus P2 is equals to 40. This is excess pressure inside a dropper formula. We are applying it to so bubble, right? So we are taking 4. P1 minus P2 is equal to 40 upon R1, and when we apply it to this P2 minus P0, then 40 upon R2. हाँ, दिवाली चल रही है, पटाखे फोड़ रहे हैं, डिस्टर्बेंस है, प्लीज़ डिस्टर्ब हो जाए मत हुए. तो अगर आप ऐड करेंगे तो ये तो कैंसिल हो जाएगा. P1 माइनस P0 40 अपॉन ये होगा, and the new radius will be 1 upon R is equal to 1 upon now 1 plus 1 upon R2. Okay. Next, the mass of air present in any liquid, mass of mass of air present in any liquid drop at a temperature T is given by W is equals to m upon RT, where R is the Rydberg constant, into P naught plus 2T upon A into volume. तो आपको ये मिलेगा इस तरह से, PV is equals to nRT, PV is equals to number of moles is equals to weight upon molecular mass. PV हमें पता है P क्या होता है, P को हम P naught plus 2T upon A लिख सकते हैं क्योंकि ड्रॉप है, not a soap, that we will write 4, and एरिया होगा ये क्योंकि हमने रेडियस को ए से लिखा है तो ऐसा हो जाएगा. और आपको वेट और द मास ऑफ एयर प्रेजेंट इन एनी लिक्विड ड्रॉप के लिए फॉर्मूला यही है. फॉर सोवेबल, हाँ वैसे ही 2T की जगह 4T कर दो और आपकी फ्रूटी टूटी रेडी होगी. नेक्स्ट, when one bubble and another bubble are like not added, like collided, just imagine they both form a big bubble. Okay, big bubble, then P naught, this is the formula. Okay, at isothermal condition temperature is constant and it is at any medium, then this is the formula. Next, when the same condition is taken in vacuum, तो फिर क्या करेंगे, तो ये वाला फॉर्मूला लगा देंगे, ये वाला सिंपल है. ठीक है, when soluble impurities are added to a liquid, its surface tension increases. Example, salt plus water. Now there is more surface tension is in a sea or in a river. How are you gonna say that? Because this fact or this reality checks it. The soluble impurities like salt in sea is more than the water in the liquid. So surface tension in sea is more than that of in river. Okay. When partially soluble impurities are added to liquid, the surface tension decreases. When partially soluble impurities are added to a liquid, then its surface tension decreases. When soluble impurities added, then its surface tension increases. When partially soluble impurities, then its surface tension decreases. Example, phenol को पानी में जब मिला देंगे तो ऐसा होगा, less surface tension, can spread easily. Now oil जब आप एक गिरा दोगे तो ऑयल धीरे धीरे से स्प्रेड होगा और पानी डालेंगे तो ये एकदम स्प्रेड हो जाएगा. ठीक है, so this is all about surface tension except capillary tubes and angle of contact. And stay tuned if you want to be tuned in this chapter. Inshallah, I will try to upload more informative videos on my channel, and please help me and by subscribing my channel. Yeah, it will make me feel really happy, and it will be worth for the efforts that I put in. Thank you so much. Bye.